Bonjour tout le monde. Hello, everyone. For those who don't know me, my name is Florian Martin Barreto. I am an associate professor of law, the University Research Chair in Technology and Society, and the director of the Center for Law, Technology and Society at the University of Ottawa. I'm also the director of the End Society Initiative, a multi-center and faculty initiative that is co-presenting this event. Today's virtual event is presented as part of our project on AI for Healthy Humans and Environment, supported by the Alex Trebek Forum for Dialogue and co-stewarded by three leading Ottawa research groups, the Center for Law, Technology and Society, the Center for Health Law, Policy and Ethics, and the Institute for Science, Society and Policy. For today's virtual talk, that is presented as part of our AI and Environment research stream, we are joined by Tara Jodoin, Thomas Graham, and Masha Guganik to discuss food security promises, technical realities, and policy approaches for indoor virtual farming. And this conversation will be moderated by Dr. Alexandre Lilo, who is an Alex Trebek postdoctoral fellow with the Public Law Center and the Forum on Water Law and Governance at the University of Ottawa. And without further ado, I will hand it over to Dr. Lilo, who will introduce our today's panelists, and then we'll moderate the Q&A session. Thank you very much.
Thank you very much, Professor Martin Barreto. It's my absolute pleasure to be your moderator today for this fascinating panel. To start with, I am speaking to you from Ottawa, where I'm on the unceded territory of the Anishinaabe Algonquin Nation. And we pay respect to the Algonquin people, who are the traditional guardians of this land. We acknowledge their long-standing relationship with this territory, which remains unceded. We pay respect to all Indigenous people in this region from all nations across Canada who call Ottawa home. We acknowledge the traditional knowledge keepers, both young and old, and we honor the courageous leaders, past, present, and future. As mentioned by Professor Martin Barreto, this event is about indoor vertical farming, and we will be fortunate to welcome three perspectives on this emerging farming method coming from Tara Jodoin, Thomas Graham, and Masha Guganik. I will introduce each speaker in detail just before they talk. So the event will run until 12:50. It's about 10 minutes per presentation, and we will have a Q&A period afterwards. So please feel free to use the chat, the conversation option to ask your question and comments, and I will be happy to share them with the panelists afterwards and to engage into a conversation. So this is an English only event. I'm happy to take some questions in French and to do some translation if needed. As you know, this is also being recorded. And I think that's pretty much all for the etiquette today. So without further ado, I would like to start by introducing our first speaker today, which is Tara Jodoin. Tara Jodoin is a policy analyst within the Innovation and Growth Policy Division of Agriculture and Agri-Food Canada's Strategic Policy Branch. She works with a team of analysts who focus on the socioeconomic impacts of the new emerging technologies like precision, cellular, and control environment agriculture to determine their effect on farmers, consumers, competitiveness, and the environment. Over the past 10 years, Tara Jodoin has worked in the federal government on projects focused on science policy, international relations, and science computing. She holds a Bachelor of Mass Communication degree from the Faculty of Public Affairs at Carleton University. Tara Jodoin, the floor is yours.
Thank you, Alexandre, Florent, Masha, and the rest of the team at AI and Society Initiative Ottawa U for inviting me to be a part of this panel today. I'm really looking forward to the discussion. I'm just going to share my screen. So in the subtitle, I wrote, Understanding the Complexity of Diversifying Our Food Production System. So Canada has a strong, well-established agriculture and agri-food system. And this puts added pressure on emerging sectors to compete, including vertical farming. So this panel is a great opportunity to discuss some of those challenges, as well as how vertical farming can fit within the existing traditional sector. The Department of Agriculture and Agri-Food Canada was created in the 1800s. So we've supported the Canadian agriculture and agri-food sectors through many changes over the years. This includes with the increasing introduction and adoption of ag tech in the more recent decade. We are a science-based department. We have 20 research and development centers. The lovely image in the back is from our Summerlin Research and Development Center. Some of the groups within AFC focused on ag tech include our scientists, our program experts, investment attraction, and market development specialists, as well as various policy experts. So this includes the group that I work with in innovation and growth policy. And as mentioned, we focus on emerging technologies, including precision, indoor ag, as well as on novel foods, including cellular agriculture. And our group is really focused on the social economic aspects of ag and food tech, including coexistence with the traditional sectors, economic and program support, public acceptance, and the ecosystems for supporting these emerging technologies. So our main priorities include supporting the Canadian agriculture and agri-food sectors in continuing to be competitive, both domestically and abroad, to help them manage risk and to embrace innovation. We also support whole of government of Canada efforts to strengthen food security, address labor challenges, and reduce greenhouse gas emissions. Our government has committed to being net zero by 2050, and this requires significantly reducing agriculture's environmental footprint. And our federal, provincial, and territorial ministers of agriculture held their annual meeting recently. And out of this, they issued the Guelph Statement. And so this is a shared vision for the next agricultural policy framework. And so I listed the 5 priority areas in the green box just on the right of the slide. And I included in brackets the climate-related wording that was tied into each of these areas to demonstrate the importance of climate action in our sector growth plan. So just a quick plug while speaking about the next policy framework. This is a 5-year investment by the federal, provincial, and territorial governments to strengthen and grow Canada's agriculture and agri-food sector. It will replace the Canadian Agricultural Partnerships, more well known as CAP. This ends March 31st, 2023. Developing the next policy framework is a long process. Each of the governments consult with stakeholders such as producers, Indigenous communities, women in agriculture, youth, and small and emerging sectors to help develop the framework. So it's currently in the development stages, and our department is continuing to seek feedback throughout this year. So this could include new and emerging challenges, opportunities for the sector, what's working well with CAP, and areas where we can improve. So I've included the email address to provide feedback. So just before I get into the policy landscape, I wanted to touch on some of the ways that our department has been involved in indoor farming for several years. So the first is through research and development. Our researchers work on open science results. So for example, we have a growth pod in Johaven, Nunavut, and AFC is working with different partners on this project. So that includes the Johaven community, the Arctic Research Foundation, the National Research Council, and the Canadian Space Agency. We also have researchers looking at low energy lighting and low cost temperature systems. The second way that we support innovation is through our programs. So we have Agri Innovation. So requirement for this one, though, is to be a first to Canada solution. So this focuses on the commercialization phase. There's also Agri-Science, which is pre-commercial innovation. We also have our agricultural clean technology programs, and this supports activities for generating greenhouse gas emission reductions. We have our local food infrastructure fund. This is under our food policy for Canada, and this supports investments in community-led projects. Eligibility for this one is non-for-profit only, and is to foster a healthier and more sustainable food system in Canada. And on this slide, you can see that we have supported vertical farms with this fund. Lastly, another avenue is a targeted approach. So we recently held Enhancing Automation and Controlled Environment Agriculture, and this was an AFC sponsor challenge through Innovations Solutions Canada. So now onto the policy side. So this is a bit of an inside look at how our group is researching and assessing vertical farming. So we're currently doing outreach. We're collaborating internally with different branches within AFC, also with different government departments, ministries, and externally with academics, including my fellow panelists. And we're trying to get a better sense of the ecosystem, the challenges, the limitations and benefits, including how vertical farming can help to enhance the food production system. So all of this feedback, information sharing feeds into considerations such as the role of the government. And while funding support is more of a well-known role we can play, we can also take on other roles, such as bringing experts together. So for example, our science and technology branch holds transformative workshops to unite innovators. So in terms of the potential of indoor farming, I'll just touch on a few of these. The sector is experimenting with existing varieties to explore their potential indoors. So we've heard about vegetable crops being able to flower continuously for years. So really pushing the limits beyond normal seasonal cycles. More tech companies are also trying to appeal to traditional growers, and some of the services vertical farming is offering is a nursery for field and greenhouse production, and also extending the growing season in Canada. So for example, Quebec-based Femme de Verre is focused on field and greenhouse farmers to grow strawberries year-round. Tech-driven efficiency is another major potential. So this includes automation, AI, machine learning, and robotics. Overall, the sector is still at the demonstration and R&D phase, focusing on gathering lots of high-resolution imagery and other data from various sensors, while working on analyzing all of that data for informed decision-making. So now onto the challenges. So high investment costs is one of the significant challenges. And some of the strategies we've heard about are community farms or joint investments. And so I'm definitely curious to know more about these types of models. We've also heard that there are still data limitations to inform and interested growers so that they fully understand what the investment is and the long-term commitment. Significant energy usage. Also has a regional consideration as energy availability and cost can vary. So exploring renewable sources and energy efficiency are also essential. Limited crop variety. So mainly these systems are focused on leafy greens and herbs, and we're starting to see a little bit more of strawberries as well too. So longer term R&D is needed, but big players are starting to get involved in this. So I've seen Bayer, Cargill, and Driscoll working on expanding the crop variety. I've also heard that advanced tech-driven systems can be intimidating to both the traditional and non-traditional new farmers. These systems generate lots of data. They have thousands of variables to control, including light intensity, CO2 concentrations, air movement, and humidity. So data standardization, analysis, and continuous tech support is needed. This big data challenge is similar to what we're also seeing in precision agriculture for field farming and greenhouse production. One of the main challenges is currently untangling the hype from the data-backed information. And this hype has increased since the start of the health pandemic and with a greater climate change focus. So this has led to a lot of pressure and overpromising to secure venture capital funding. And what we've heard from the sector is that this is negatively affecting public dialogue before the sector has time to organize and prove itself with standards and scaling. So an article that recently got our attention was written by Henry Gordon Smith. He's the founder of Agritecture. And just on the right side is where vertical farming stands, according to him, on Gardner's hype cycle. And what's needed is more transparent discussions on the reality of controlled environment agriculture to move into progression and productivity phases. So really moving beyond the greenwashing overpromising, such as vertical farming can feed the world, into discussing and working on the limitations of these systems. So currently, economic analysis, return on investment, production costs, labor, and carbon footprint analysis are limited. So more data can lead to informing coexistence discussions, better business models, and attracting and retaining new growers. So just in the interest of time, I won't go into detail on this one, but I just put this slide together based on some of the discussions we've had with some that have said that they're interested in vertical farming. Others I've looked into have support available under more general programs, and some are actively focusing on vertical farming. So this is my last slide. So some of the areas I'm going to be digging deeper into, I really want to explore the coexistence with traditional production methods, the supply chain models, how other governments are supporting vertical farming. I want to look more into the potential of urban agriculture, and I'm going to continue to do outreach. I'm going to continue to collaborate with other experts just to see what else I can learn. With that, I will say thank you very much.
Thank you so much, Tara. It was very insightful, and I'm sure we'll be able to discuss that further in the Q&A period. Just a reminder for our participants, please feel free to use the chat box, the conversation option to ask a question or write a comment. We'll be, monitoring what's going on in there, and we'll be discussing those comments and questions in the Q&A period. Our second speaker today is Thomas Graham, which is an assistant professor in the School of Environmental Sciences. He holds the Phyto-Grow Research Chair in Controlled Environment Systems at the University of Guelph. He completed a prestigious postdoctoral research fellowship at the NASA's Kennedy Space Center and returned to the University of Guelph, where he continues to develop a broad-based interdisciplinary controlled environment agriculture research and teaching program. His research activities encompass many international and domestic collaborations covering such topics as bioregenerative life support for human space exploration, northern and remote community food insecurity, high-intensity urban and peri-urban agriculture, medical crop migration and standardization, control environment agriculture, water remediation, and plant environment interactions and optimization. Dr. Graham is also active in STEM outreach activities through such programs as Tomatosphere TM, and he sits on several journal editorial boards and is an active peer reviewer. Dr. Graham, the floor is yours.
Thank you very much. Let me share my screen here. All right. Well, I put that first slide up just to show first of all, I'm here to talk about the technology side of vertical farming. And that first slide sort of walks through where we've been and where we're going in terms of vertical farming, plant factories, whatever you want to call it. Controlled environment agriculture is probably the most broad encompassing term. So for today, I want to talk as well about the many faces of controlled environment agriculture. It is certainly multidisciplinary and it covers a wide range of technological sectors. This collage just shows some of many. And I'm going to crash through a lot today. This is recorded, so you can come back and look at it at your leisure or contact me directly. I'm happy to talk about it. First thing I want to touch on, though, is what vertical farming or controlled environment agriculture isn't, and it is certainly not field production. We are a long way technologically and economically from even considering growing staple crops indoors. Someday maybe, but we're not there. We don't need to be there for a while yet. We're also not this. These fantastical things do more harm than good, in my opinion. It's setting unrealistic expectations. This isn't what we're doing. This is more what we're doing. we are growing plants in a box. And why do we do that? Well, there's lots of good reasons. One is climate change, or climate mitigation. We're not doing, or adaptation, I should say. We are adapting with vertical farming and controlled environment agriculture, our agricultural systems, to a more chaotic environment. You can't, there's not many that would say this is an ideal growing condition, but with controlled environment agriculture, we can exclude that. The things that challenge field production currently are weather, that's a big one, critters, pathogens, pests, a whole suite of unknowns that we don't even realize yet, and weather, keep coming back to that one. These things are, to varying degrees, unpredictable and uncontrollable. Now, we do our best, but indoors, they are. Now, this is a slide that I present to my third and fourth year students. So we have in the center some mystical plant here that provides food. Plants can provide medicine, and they can provide psychological well-being through just being pretty, floriculture. Now, the challenge of controlled environment agriculture is that a lot of things impact that plant. Everything around it, its environment, everything that we can control and can't control, impact that plant. But the real challenge and the technological drivers of controlled environment agriculture come into play when you realize that of all of these factors interact. So if you change one, for example, light, it has an impact and changes how the plant interacts with all the other parameters as well. So understanding and being able to control this requires a lot of hardware, automation, sensors is a big one, but it also requires things like AI. This gets chaotic in a hurry, and our gray matter can't handle it. We need bigger systems to be able to manage this. So that's a technological challenge to be addressed. Why would we do that? Why do we need to do this? Because we can garner a lot of benefit from growing plants, our food, our flowers, our medicine in a box. We can do better than nature in a lot of cases. We can manipulate the environment to modify a plant to do what we need it to do. The terminology being batted around right now is environmentally modified organism. A plant is how a plant develops and turns into food is regulated certainly by its genetics, but equally so by the environment that it grows in. And this picture of this lettuce, for example, those are all the exact same genotype grown at exactly the same time under exactly the same conditions, except the color of the light. And yes, there are differences in the amount of food that's produced. The red one is a bigger plant, but it tastes much different than the one grown in blue, which has a much higher antioxidant content. So you can start to mess with the nutritional composition of our food and tailor that nutrition composition to our specific needs reliably and repeatably. And there's also medicinal compounds too, both medicines and phytopharmaceuticals, or medicinal herbal medicines and phytopharmaceuticals that can be modified and manipulated and controlled in this way as well. So I come back to this slide with all of these things on it. Again, just to help you realize that the technology driving all this, some of it's here, some of it's ready, some is under development, and some we still got a ways to go. Given the topic of today, I did want to touch on my own research program and food insecurity in general, and how vertical farming or controlled environment agriculture can address that. And I won't go over the definitions of food insecurity, they're almost intuitive. How I came to have an interest in this is I spent a solid decade of my formative years in the summers up on Devon Island, built a greenhouse. But during that time, I spent some time in the communities, and even going through their co-op shops there where they get their groceries, and realized just how food insecure they are, the cost of things. And there's a lot of good reasons to address food insecurity food insecurity is a big problem, and vertical farming or controlled environment agriculture is only a part of the solution. And so I'm not saying it's a panacea, but there are good reasons. For example, in Ontario, if you are severely food insecure, shown here, this drain on our healthcare system is double what it is if you are food secure. So there are a lot of good reasons, both altruistic and not, to start to address these issues. And it can be done. The technology exists. In these northern and remote communities, this one's Churchill. There is a fresh produce production system in Churchill. In the dead of winter, they're producing mostly leafy greens, but quite successfully. There's 800 people in the town, and they can produce a fresh, better produce for about half the price as it takes to fly it in, which is how it's usually done now. And when you fly lettuce in, it's not very good. But it's also cross-pollinating cultures. So here, okay, is lettuce a traditional northern food? No. Is bok choy? No. But it goes good with caribou, apparently. So there's these real opportunities for social interaction and cultural interactions. Tara mentioned the work up at Joy Haven. Same idea. These systems are available. They do work, and they can engage the community. There's people that have never worked in agriculture in their lives, but here they are. Here's Betty and her husband, Sammy, who's not in the picture, really taking to this and wanting to show or broaden their experiences and deliver what they're learning to other communities in the north. We also have done a lot of work with our international partners. We have life support or food production in a very food insecure place, and that's Antarctica, the German Research Center there. So here, and it's a very beautiful place, by the way, they are locked. They cannot come or go for 6 to 8 months of the year. And there isn't many fresh things that last 6 to 8 months. So their diet is limited, and that can have a real impact on your psychological well-being, not to mention your health, just from a nutritional perspective. Things like, vitamin C degrade quickly. So we built a chamber for lots of reasons, but one was to supplement the crew's diet with fresh food. And this, when you're stuck in the Antarctic night and you can have fresh strawberries or tomatoes, that makes a real difference. And the same for northern and remote communities in Canada. But it doesn't have to be minus 50. It can be plus 50. It's the same problem. It's the same technical challenge in a lot of cases. So we've been working with the Kuwaitis, who realize that oil will run out someday and they need to feed themselves. They are working towards that. And how do you do that in the desert? You do it inside. And the Middle East is one of the biggest markets right now, or areas of development for these systems, for these reasons. I also wanted to touch on medicinal aspects. Vertical farming isn't just about food, it's about producing medicines. And there's many good reasons to look at crops that have endogenous medicinal compounds. Cannabis is a big one these days, but there's lots of herbals. And one of the reasons is our supply. A lot of people take these, okay, the clinical trial evidence is a little bit weak, if it exists at all, but a lot of people are consuming these things. And I'm not picking on China at all here, this just happens to be a sample, but we're getting these medicines from outside, you can have some real problems. And this is just a map of soil contamination risk, and all those little black dots are known as cancer villages. Well, guess where a lot of our herbal remedies or medicinals are coming from? And in addition to that, they can be adulterated with, human nature is, human greed is always in play, I guess, and people add, Tylenol, for example, to get some effect. So there's a real good reasons to bring things into controlled environment agriculture, where you can control everything, you can produce it locally. You can also start to impact or preserve our natural ecosystems that support some of these medicinals. For example, golden seal is very common herbal, but it's also endangered in Ontario, in Canada, from overharvesting. And when you bring these things into controlled environments, you can also accelerate how quickly you can produce them. So there's lots of good reasons, again, to bring crops of all food and otherwise into controlled environment agriculture and develop the technology. And when I say technology, that includes just management practices. How do you grow these things? There is also transgenic or recombinant things. For example, I'm on a clinical trial for a COVID vaccine that is made in this very way. It's made in a plant, and it's Canadian made. That's the Medicago trial, if anyone's interested. So there's a lot of potential here as well. And again, the technology required to standardize and be able to produce these medicines consistently over and over, year to year, are important. And some of them are we're still working on it, but a lot of them are in place. It can result in things like edible vaccines and easier ways to get medicines to people. And I just want to close now with just a real quick touch on space applications, life support. Canada, along with many other nations of the world, have committed to going back to the moon and beyond, to Mars, with long-term or potentially permanent habitation. The only way we can do that, to realize this sort of dream, and I point out the big green dome there, is to take plants with us, is to take vertical farming with us. I'm sure a lot of us have watched The Martian. Survival was based on plants. We need plants if we're going to leave Earth for any length of time or any distance. And the CSA, the Canadian Space Agency, has teamed up with AAFC, Agriculture and Agri-Food Canada, as well as the Arctic Research Foundation in these northern communities, to develop these systems. Because if you can do it there, if you can do it on the moon, you can certainly do it in Joy-a-Haven. Or if you can do it in Joy-a-Haven, you can probably do it on the moon. And that's the link, and that's important. So regardless of where we go in space, we need bioregenerative life support systems. And they can be complex, but as is vertical farming. And usually when you provide someone with this particular definition or show this, it's like, yeah, you get this. But it doesn't have to be that complex. Life support, vertical farming, it is controlled environment agriculture in space. It is space farming. It is vertical farming in space. And that's what we have to do if we're going to venture beyond Earth. Simply because plants provide us oxygen, they provide us food, they help us clean water, and they make us feel good. And luckily, if you go to space, you're limited by how much you can take. And luckily, plants and vertical farms are regenerative, so you don't have to keep taking stuff. Things start to whip around in a circle, and our waste is the plant's food and vice versa. And that is the basic concept of bioregenerative life support. And just to show how all this relates, one of the first probably documented true vertical farms was built at NASA. It's called the Biomass Production Facility or Unit. And this was back in the late 80s. And this is, that's why the photo's so grainy. But this was true vertical farm. And from NASA's program there, seed potatoes, for example, they showed that you could grow potatoes hydroponically. And now a lot of seed potato producers use this very technology to grow their seed potatoes. More recently, we are going back to the moon. Canada has a stated interest in being the lunar farmers, and University of Guelph is a big part of that. We've been involved with the Deep Space Food Challenge, my own lab, along with Mike Dixon. They were one of the semi-finalists. I couldn't be involved because I'm actually a judge. I co-chair the selection committee with Chris Hadfield for the Deep Space Food Challenge. So I encourage anyone interested in vertical farming in space applications to go check this out. Because this was set up as a technology driver to encourage the broader community to start to contribute to the technology of spaceflight and vertical farming in space, with a very strong Earth-looking application. Everything we do to grow food and support people on the moon and Mars has an immediate and absolute tech transfer to Earth. And with that, I will wrap it up. And I don't even know how far I went over, but probably pretty far. Thank you.
Thank you very much, Dr. Graham. We have a bit of flexibility in terms of timing, so that's totally all right. And thank you for sharing this fascinating presentation with us. I'm sure we'll have very interesting questions about that. I do have a few questions myself, so I'll keep those for later. But thank you. And maybe I can ask a quick question to Tara and Thomas, and that's maybe a bit parallel to what you discussed. But I was thinking about, more and more we tend to hear about this nature-based solution and to come back to a more natural way of farming. And I'm curious to what kind of opposition you face, talking about indoor vertical farming that is, like basically a technology. So I'm super curious about if there is a clash of worlds or if that's something that tends to work well together.
Tara, do you want to take that or you want me to jump in there?
Just to clarify, is this coming from a consumer or from which perspective?
It's coming from curiosity, I guess. I'm just
Okay, so just in general?
Yeah, in general. Yeah, totally. It's just, like this ethical question of, I want to say manipulating nature, but I don't want it to sound in a bad way because I'm not, opposing to that kind of practice. It's just like the movement that we can see and the ethics behind it.
Yeah, no, absolutely. I can start, and then Thomas, I don't know if you want to jump in after, but in terms of, I was thinking from a consumer perspective, because as far as I know, and what I've seen in different studies is that consumers aren't really aware of what vertical farming is. There's already vertical farming products that are on grocery shelves, but they're mixed in with the others, and unless they actually read the label, and even then, if they read the label and see it. So in terms of natural growth, yeah, I can't see, and whether consumers even care or not, whether their plants are being grown, with lights instead of with the sunlight. And there are some retailers that are starting to have vertical farms and on a smaller scale inside the grocery store to help to educate that. In terms of just overall and say like a coexistence model, we're using technology involved in plant breeding innovation and in precision agriculture, using other technologies, not just with indoor farming and greenhouses and with vertical farming, but also with fields. So I think there's a lot more understanding that we find ways to be more efficient and to use AI and automation and robotics and all of these tools to be able to meet the bigger demands that we have and the bigger goals of food security. And we have a growing population and dealing with climate changes and being more climate efficient. So I think there is more acceptance overall that we need to find ways to evolve to meet some of these bigger challenges.
I guess I would just add to that. I mean, you'll always have the fringes that will just not accept it, but that's fine. I would argue that these systems, okay, they're not all sustainable, but I would put more in a sustainable label than I would, for example, organic or natural or anything like that. But what is unnatural about a plant? So a lot of it is education. But I think not all these farms will be in the city, but some will be, and they'll be visible. So I think it's an opportunity to re-educate. A lot of people don't know where their food comes from now. They don't go to the fields. They don't see that. But if they see a vertical farm or a greenhouse next door, and that's where they're getting their food, there's more of that sort of in touch with where their food's coming from and appreciation for it. But as these systems develop technologically, the sustainability, the energy efficiency, the inputs will go down. And I think, again, you'll always have your fringes, but the general masses, I think, are pretty accepting of it.
Thanks, both of you. It's quite interesting to see often with like, with innovation often comes down to education and the big learning curve that comes along with it. So our last speaker today is Dr. Masha Guganig. She is the Alex Trebek postdoctoral fellow in AI and environment at the University of Ottawa AI Plus Society Initiative. As an anthropologist and science technology studies scholar, her work looks at controversial technologies in food production and how actors both construct and question nature technology binaries in practice and discourses of high and both slow and low tech farming. In the case of indoor vertical farming, she studies socio-technical vanguard problem framing to legitimize the high-tech urban food production system. Dr. Guganig also designs and deploys art-based research methods, and as a curator, she's currently planning the symposium and exhibition, The Smartification of Everything, that will be held at the University of Ottawa. Dr. Guganig, the floor is yours.
Thank you, Alex. Well, I want to take the second to thank everyone for coming here for the panel. It was truly nice to see that we got people from different perspectives to come together. Hi, everyone. So my name is Masha Guganig, and I will be talking about some findings that we had from a project that we did a couple of years ago in Europe. And that was a project that was funded by the European Institute of Innovation and Technology for food. And it was a collaborative project with an indoor vertical farm company and a science communication partner. And we actually discussed these questions that we were just talking about in terms of acceptance and what does it mean to accept? What are factors for people to think of vertical farming as a viable, or indoor vertical farming as a viable future food option? And we did, one of the findings was certainly that most people did not know about it. It was not, and I would argue still is not. It's sort of slowly growing to become more prominent in public space, but it's a much more of a niche development. And we did citizen participatory formats that we've already published on, and we also were interested in vertical farming per se in itself. One of the findings that we had was that vertical farming, the terminology, the term itself, it's quite malleable. So some people would also consider rooftop farming as vertical farming. Indoor vertical farming seems to be a better delineator of the kind of controlled environment agriculture. So we interviewed primarily researchers, but also startup owners and consultants from several different countries, and I'll be mostly speaking about results from those interviews. So just a bit of a background from my disciplinary training or my perspective. So in science and technology studies, or STS, and also in anthropology, which is my other field, scholars are interested in sort of understanding where do people draw this, not all of them, but some, where do they draw this division between nature and culture? So anthropologists particularly look at that, and where does technology come in, and what are factors where people draw that distinction? And I would actually argue that it has not always something to do with education. There are sort of very deeply rooted social values and cultural values, and how a long history of what good food, healthy food is in culturally specific contexts. And STS scholars also look at how technologies sort of become the solution for what kind of problem. And there is this assumption that these achievements of scientists and engineers almost translate naturally into these solutions of these grand problems that we're dealing with, and now even more so with climate change. So one of the things that scholars have pointed out is that it's tricky to be framing these issues extremely grand and large. Obviously, we have them, but for technologies to be becoming the solution for them is almost doomed to fail, because it is at such a grand scale. So my question that I was then sort of inspired or motivated by is not so much what are the technical details, though I was interested and continue to be interested in how sort of, for instance, LED lights get redefine also what is a plant through scientific studies. But I was also interested in what are these problem framings that that proponents have, and where do they see, or that they propose, and where do they see vertical farming as fitting in? So this is a book that came out in 2010 and really inspired I would say a movement of socio-technical vanguards of vertical farming. So startup owners that were really interested in applying their technical expertise and their engineering in something as food production for urban space. And Despommier, who is actually a parasitologist at the Columbia University, held this seminar with his students, and they were quite thinking broadly and speculated what would it need to grow food for a city like New York, and so what would it need? How much space would it need? And one of the things that he lists in the book are all of the benefits that such systems would bring. And the kinds of systems that he was talking about, where like the architectural rendering that Thomas was just showing before, really buildings that only would house plants to grow. Now, there are many benefits to it, but again, what is the setting from which we talk? And as was already sort of alluded to before, vertical farming is not necessarily something that everybody agrees is the most sustainable way to be growing food. There has been critique in terms of the energy use. So if you consider the fact that everything is layered, you need obviously much more lighting systems than in a regular greenhouse. There has been critique over the fact that lots of venture capital goes into these systems, while there are many bankruptcies reported as well. Since 2015, there's over $1 billion that has been put into these systems, and it has shown that the ones that survive are really the ones that are on a very large scale, operating on a very large scale. And another critique has also been that this might not necessarily be the only, or it's often framed as sort of the only way to be growing food in the city. And so I'm thinking of vertical farming with a concept by STS scholar Steve Hilgartner, who's at Cornell, what he calls vanguard visions. He describes this as a vision among a small but very heterogeneous group of socio-technical vanguards that see science and technology for this future that they see as attainable, but that hasn't really been widely accepted or widely shared. And part of this vanguard vision is to cultivate future vision, socio-technical future visions, not necessarily only to convey the sense of this is the kind of future that we're going into and this is the kind of attainable future, but also as a long-term potential for investment and technical development. So many venture capitalists are very aware that they are sinking money into something that might not necessarily generate income for them right now, but it will lead to more technical development. And so part of these visions, the way that they are operating is that they often employ conceptual templates or scripts or metaphors from other high-tech fields. So one of the major claim that is often made is that we are completely redoing and transforming agriculture. And the other panelists have already mentioned that this is sort of quite hyperbolic, these assertions. One of the sort of conceptual template procedure is to control settings. So we've already heard about this. This is something that has gone, this is to control a space to grow food is something that humans have done for many, many centuries. Horticulture as a science has been established for the last decades. And so it's sort of like bringing this to the next level. There's also a sci-fi aesthetic, so this purple light that was very popular for a long time, it still is, that many found, some of the interviews said, like, yeah, it's a very sexy kind of color, like people really can be drawn to this. Instead of, it has this sci-fi effect, even though it is only about growing food, and there's this hope to attract more young people to get into farming, even though farming, it might not necessarily be too attractive per se. And so the other template that I was mostly interested in is, okay, how does the problem framing help to sustain that this is to justify that indoor vertical farming is something that is needed for future food production. And so this is primarily the one that has also been critiqued to be feeding the world with these kinds of systems, or at least help to feed the world. So this goes back to this narrative that we all know quite well. We have to feed 9 billion people by 2050. So this is also something that has motivated lots of venture capitalists to fund vertical farming operations, and in their understanding to diversify their portfolio, to be doing something more sustainable. Anybody, and that was something that one consultant shared with me, that as soon as they heard we're going to feed the world, they were willing to spend much money on these systems. Another thing that we found also with the researchers is a big unease with this kind of framing, because it's not necessarily reflecting the reality of what is able to be grown right now. So as Thomas was saying, this is not replacing field agriculture, but it's often framed as such. Now, when we go back to this narrative of feeding 9 billion people, we will find that this is actually a little bit flawed, because in this report that was published by FAO in the early 2000s, there is actually no mention of fruits and vegetables. It's commodity crops, it's starch, it's calorie crops. And it's assuming it's focusing very much on the commodity shift from cereals to meat and animal products, particularly in the global south. It also neglects food waste and uneven food distribution that might not necessarily directly link to vertical farming, but to latch onto this narrative and to miss the fact that this is actually a very different kind of food. Because who are you going to feed with lettuce? Who are you going to feed with tomatoes? It is a growing portfolio of kinds of foods that are grown, but it does not feed anyone in a substantive way to diminish food insecurity. So when we think of vertical farming, how it is framed in order to respond to this problem, or to find, act as a solution, there is a very strong narrative of what we need is a very sterile system, a controlled system where you can, basically control all of the factors, which can be very good for many reasons. At the same time, it portrays a kind of future vision of food production that might not necessarily consider other forms of food production, like with soil or outdoors, or in systems that are much more intercropping, or crops that actually need that kind of diversity, and sterility would be very detrimental. And the other thing that it latches onto too is, and obviously this makes sense because there is a lot of research that has that comes through research in outer space, is that it portrays Earth as a state of perpetually extreme conditions, which, to be frank, is the case. We are moving into extreme situations, and whether it's climate, whether it's war or the pandemic. But it also begs the question: is this the only way to deal with it? And how did we actually get there? So there is a tendency to standardize what is understood as sustainable food production for the future, that we have to ward it off from any extreme conditions, and it leaves very little space or imagination for anything else. What, for instance, would you do if there is a flood that also washes away a vertical farm itself. It's not immaterial, right? Like it's not something that is sort of out of the world. So to conclude, vertical farming as a vanguard vision can be understood as it's this diagnosis and the alignment of what these grand problems are that are rendered just as technical as vertical farming, that it happens at the right time. You have to have the right capital flow. There was a very particular time of venture capital, lots of venture capital going into these systems. The environmental urgency that leads a lot of brings a lot of support for these kinds of systems. The political discourse, as well as now the pandemic, where vertical farming sort of appears, and I think this was a question that came up before in the chat, as if it were applicable universally, and it is, but it certainly has a different effect and different benefits in a place where you have a water scarcity, in a place that is that does not, or in a place that has lots of sun, or in a place that does not. So a differentiation is often missing. And then that it will eventually become technically sophisticated just as much as society ought to become technically sophisticated in the future. And just to wrap up quickly, these are some of the problems that I found in this study that are often sidelined, and I believe that they're quite important, and some of the interviewers also shared them. And the first one being like, what are these problems that are dealt with and which ones are not dealt with? So what are other forms of food production they might not necessarily be getting that kind of financial support? What is the significance of land and soil? Vertical farming is often renders agriculture per se as bad, where it's much more specifically a very highly industrialized monocultural agriculture. How did we get there? This kind of question is often sidelined when we are adapting to a particular earth and an environment and climate change that we are in. It's still important to ask how we got there and what are other alternatives than highly technical systems that require lots of automation, that require lots of energy, that require particular forms of expertise. Which leads me to the next point, expertise and labor. What kind of labor is created? What is the kind of expertise that is also appreciated and paid for? So if you automate, one startup owner that I talked to wanted to automate everything, wanted to actually have no human in the system itself. So the human per se becomes almost like a virus that should not be touching the plant at all, only until the human eats the plant. That's a very different vision of the human and the kind of food that the human produces for themselves. Another point is gender that came up. There's a very strong sort of male bro culture that many women found extremely hard to get into. This is also something that's been published on, and increasingly a topic just as much as diversity, equity, and inclusion. What are these aspirations? There are lots of projects, like Thomas was referring to, that are very much based in communities and that bring people together. And vertical farming can really be a stimulator for people that are very different backgrounds to come together and to actually ask, okay, where does our food come from? Where, most of our food is already grown in greenhouses. Is this natural? Is it artificial? Where do we draw the line? And I think we need more of that kind of open discussion. So I see vertical farming also as a very important educational space for agricultural systems more generally. How do we actually produce our foods? And then finally, the question of where does the money come from that funds these kinds of projects? Increasingly, there's more research funding. In the beginning of the industry, it was primarily venture capitalists. But we have to ask that question: if venture capitalists are driven by the motivation to be feeding the world and to be throwing millions of dollars into systems that are growing lettuce, and then eventually these many of them close down, we need to ask more: what are all these other factors? What social groups are catered by this? Or is it sort of to get as much revenue out of it so that we can please the venture capitalists and the investors? And that's it from my side. Sorry, it was a bit longer, and I look forward to the discussion.
All right. Well, thank you so much, Dr. Gugenig. That was very insightful as well. Okay, so that wraps up our 3 presentations for the day. All 3 very fascinating, and I'm quite new to this topic, and I feel like I'm being in this new matrix production, except with plants. So it's quite fascinating to hear about that. It's going to be time for the questions. So please, once again, feel free to use the chat box, the conversation option to ask questions or share comments. And the first question that we have for our panelists today is about the cost of electricity, specifically in the north, and electricity needed for vertical farming. And so the question is the following: is indoor vertical farming more financially viable in the south? So that raises the question of electricity, but probably maybe other resources needed to come up with that kind of solution. So I don't know if anyone wants to hop in.
Yeah, I can go first, I guess. There have been studies done on this, and it turns out it is quite feasible, as long as you're not having to run your greenhouses and growth chambers on diesel. That's a non-starter for lots of reasons. But whether it's more feasible in the north and the south, well, I think in my talk I showed some, and it probably crept up other places as well. If you're paying $7, $8, $9 for a pepper, that's a pretty big margin that you can come in under. Like the Churchill example, they're growing indoors in Churchill and still coming in at half what it would be to fly that stuff in, and it's fresher, it's more nutritious because it is fresher. You haven't had the vitamins and whatnot degrade. So, and it depends on the crop. Lettuce, maybe not, but strawberries, for example, you can make money. It depends. It always depends.
So it's interesting because with that kind of solution, it breaks the concept of seasonal veggies or fruits or regional veggies or fruits. So that I guess that takes a bit of rethinking as well and reconceptualization. Masha, Tara, do you have anything to add?
I would say Thomas is definitely the expert on this, so I have nothing to add to his comment.
I would just add to this that one thing that's often forgotten is that these systems. This is something that one researcher shared. It makes a difference if you sell cannabis growing in these systems, or if you're trying to sell lettuce. So obviously, as Thomas was saying, it depends. It's relative. Whatever you are getting from in terms of the what is it that you get on the market for the products that you're growing. In that sense, the energy costs make more or less sense, or are more or less something that you can put off by what you get for the products that you sell.
And I'd just further add to that too, don't grow potatoes or things that you can store for months. That's not feasible, and it doesn't need to be. So it's target the crops, target the local resources. Are you in the tundra, or you're in the boreal forest when you're north? Is there do you have biomass energy supplies, or is it strictly solar and wind? Again, it depends. So.
All right. Well, we have another question, and I'm gonna. It starts with a comment and goes to a question, so I'm gonna read it to you. Vertical farming is widely reported to be protected from pests, and therefore pesticides are not required or used. However, anyone who has grown plants in protected environments knows that they are susceptible to a diverse array of pests that can have a serious impact on crop health. How would uses and risk of pesticides in vertical farming be different from other control environment like greenhouses?
You want me to go?
Could you go ahead? Absolutely.
That's an excellent question, and it's one that I bring up in most of my talks. Yes, there's this greenwash or notion that you will never have a disease outbreak, but these 10 things are incredibly dirty. So if, despite our best efforts, there will be things that get in. Things come in on the media that you're growing your plants, and things come in. So you do still need things in place. For example, root zone management, you need disinfection technologies that are typically non-residual forming and are quote unquote clean, things like UV and ozone and peroxide, things that aren't toxic to us. But yeah, it's a fallacy to think that disease and other things aren't going to get in there. You know, listeria, I can assure you, will grow in an irrigation line as well as it will a HVAC system. So that said, compared to greenhouses, you can close, the tighter the closure of the loops, and this is where the space stuff comes in a little bit too, the more control you have over that. Are you HEPA filtering your air that's coming in? Yes or no? You know, there's lots of things that can be done, but no, you will not completely exclude these things, but you can go a long way to reducing the need for pesticides and whatnot.
Thank you very much, Thomas. Masha, Tara, anything to add on this question?
The only thing that I would say is depending on the size of the vertical farm. So I've heard some of these bigger warehouse, humidity is an issue. So dealing with mold and other types. Yeah, that though it's more of a technical area that's not in my area of expertise. So again, Thomas is the expert in this area.
Well, that's a good point,
Right.
Tara. And there is technology emerging for stuff like that as well. Yeah, scaling up can be problematic from some of those perspectives. So can scaling down. Actually, that can be equally as difficult.
All right, thank you very much. I should say that we have about 5 minutes left, so hopefully we can answer maybe 2 questions. So the next question is the following: are there currently any initiatives used to inform consumers about the benefits of vertical farming without giving these types of products a bad reputation? And the participant takes the example of GMOs and I guess what we talked earlier about and the learning curve and the education needed with that kind of technologies.
So
I can, sorry, go ahead.
Yeah.
Yeah, so I'll just say I've started to see some of the companies are starting to develop these vertical farming universities, starting to try and have that discussion with consumers. I would say it's still very early on, and because there's a lot of that over-promising, I think maybe that needs to be built into it so that they really understand what the benefits are, and having some data-backed conversations with consumers. Consumers are a lot smarter, you know, that they really want to know where their food is coming from. They want more details than what they've ever had before. They're very invested in you know, getting involved in trying to help with some of these climate issues, and as well with trying to improve food security. These are of concerns to all Canadians, and so I think this is just starting to happen. And who should be leading on these types of initiatives? I think that's still up in the air at this point.
I just wanted to add to this because we did, this project was sort of a citizen participation format that we applied or developed. And the thing that we found, and that's also something that science and technology studies has shown over and over again, particularly with GMO, which is it's a great example where it might not necessarily be the right approach to be trying to lead the conversation away from something that people are already fearing, because the vertical farming communities and the startups were already, that was the very first thing that we learned, like we don't want to have a second GMO debate. that is absolutely understandable. But I think it will bring more trust and more buy-in when people have the space and the data, as Tara was saying, the evidence for people to make up their own minds. And for anyone who decides to not want to have lettuce grown indoor, there are so many reasons why not to. What about soil health? What about so for instance, so there's sort of this individual level, but then there's also the policy level. When you look at the European Union, the label for for organic farming, you could not even do that indoors. In the United States, they actually changed that, so you can grow hydroponically. You don't have to have the soil as one of the factors to be defining something is organic or not, if that is important for people. Again, I think that vertical farming is not just sort of it's not just it's a space, or it's an industry that has inherited a lot of these debates, a lot of these controversial technology debates, and it has to face that, because you're not going to get away. You're not going to be able to sell something if people are suspicious, and for often for good reasons. So I think the approach to acceptance, I think, needs to shift a little bit to a more open-minded discussion to be had.
Thomas, do you have anything to add to that?
No, I think that was covered fairly well. We do have a project, hopefully, to be funded that will look at consumer preferences and, for example, what they're willing to pay, what a vertical farm or sustainable versus organic means. And I think once we understand that a little bit better, that will arm the growers with, well, marketing fodder ultimately.
All right, thank you very much. So I think we can take maybe one last question, and I'm going to choose this one with a bit of discretion and with someone with a lot of background. I'm going to ask you, and I'm going to tweak a bit the question as well, so bear with me. So short answers only. Do you believe in food self-sufficiency on a provincial or federal scale? To what I would add, what is the biggest challenge left to overcome to reach the vision that you shared with us today? And there was a third part to this question that I actually forgot. So let's stick to this, and maybe we can do a little tour de table, starting with Masha.
Okay, thank you. I think that yeah, it's an important question. To what extent food self-sufficiency is even desired. So we live in a highly globalized world. People have their preference in terms of exotic fruits. That's not to say that they should continue that, but it's also a very important question for policy level, for industry, for individuals to be asking what is it that I desire and what I need. And I think it's not really a complete it's not a black and white matter. I think that we really have to reflect on all of these levels. To what extent is it even feasible, and how can we support from the policy level more regional food production? What kind of regional food production? That's another thing, right? So and to what extent are others that are globally distributed and imported? Would that even make sense to grow certain? Obviously crops can't grow in many places if it's not energy efficient.
Thank you, Masha. And your answer actually allowed me to remember the third part of the question, which was, what would be the impact of food self-sufficiency on the global food market, and if that would change? Well, I mean, it would be probably massively disruptive, but I would be interested to hear your take on that if you have a few seconds. So maybe Tara, you can share your insights with us.
Yeah, so just to build on what Masha said about whether it's even feasible, at this stage, we're still trying to gather, or the industry is still trying to gather the data to be able to build into these strategic business cases and market analysis of where we can fit vertical farming in within pockets within urban regions or remote regions, or you know, to help to improve self-sufficiency. And Canada we have a very strong, robust agriculture and agri-food sector. We are an export nation, and that's not going to change. We have goals to even, you know, expand and to continue to grow our export abilities. But I think there's definitely like room for both. We can continue to grow and expand what we can do with exports, and also find these pockets of where we can improve food for Canadians domestically with domestic production. So I think it's a complex answer, and there's going to be a lot of different variables, and it's going to happen over the next couple, I would say even into 10 years as the technology develops and we start to see more modeling and more actual data from it.
Thank you so much. Thomas?
I agree with all of what's been said to date. Do we need complete self-sufficiency? I don't think so. We are a global community. You know, in the high season, Canada's an exporter. You just flip that on the head in the winter. But do we need the capacity or the when things like COVID hit and turn the world on its ear? Yeah, we need that capacity, both in our food systems and apparently our healthcare, to respond to that. But I don't think we need to be 100% self-reliant yet. It's, you know, again, we're a global community now, so, and trade goes both ways, and trade is important.
All right. Well, unless there is a very last burning comment, I think we can wrap up this event. Before we do, I would like to thank the sponsors for this event, which are the AI Plus Society Initiative and the Alex Trebek Forum for Dialogue at the University of Ottawa. Of course, I would like to thank as well our three wonderful panelists for sharing their work. It was very insightful. And thank you also to our participants that attended this event today. The event is recorded and will be available soon online. And with all that, I wish you a very wonderful day, and I hope to see you soon.